Yeah.
Yes.
We just started the webinar. Let's
in finance and digital economy, bi-weekly events and meetings, webinars and seminars. It is my great pleasure today to introduce our guest speakers in our bi-weekly webinars and seminars, Professor Rick Watson, Professor Xia Zhao, and April Song. They will be talking about Theory Research Exchange Project, which is a new approach and supporting technologies that enable researchers to code the causal and process models in publications as graphs and extract and synthesize ideas for the extant literature in a speedy and exhaustive format. Now, let me introduce our guest speakers and panelists for today. We have Professor Rick Watson, or Richard Watson. He's the Regents Professor and the Rex Fogwa Distinguished Chair for Internet Strategy in the Terry College of Business at the University of Georgia. He is a former president of the Association for Information Systems, and for about a decade, he was a research director for the Advanced Practices Council of the Society for Information Management and a visiting researcher at the Research Institute of Sweden in Gothenburg. Professor Watson has published over 200 journal articles and written books on electronic commerce, data management, and energy informatics. His most recent book is Capital, Systems, and Objects. His work has been accepted by leading academic and practitioner journals and has been translated into several languages. Professor Watson has given over 300 invited presentations to practitioners and academics in more than 30 countries, including conference keynotes on 6 continents. He was educated at the University of Western Australia, Monash University, and the University of Minnesota. And also we have with us Professor Xia Zhao. She's an assistant professor of management information systems at the Terry College of Business, the University of Georgia. She received her PhD in management science and information systems from the University of Texas at Austin. Her research interests include platform economy, IT governance, artificial intelligence, and information security. And she has published in the leading information system journals, including Information Systems Research, the Journal of Management Information Systems, and other leading journals like the Journal of Retailing, Decision Support Systems, Decision Science, and so on and so forth. And also we have with us April Song, and she is a PhD candidate in the MIS department at the University of Georgia. She is working on Theory Research Exchange Project under the guidance of Professor Watson and Professor Zhao. Her research focuses on advancing the practice of literature reviewing and knowledge synthesis using graph analytics. And she has published papers in the ISI conference and the AMSIS conference. And she also serves as a reviewer for several IS conferences. Thank you all for agreeing to coming and presenting your interesting project with us. And the floor is all yours.
Thank you, Mazen. Thank you, Musa, for setting up this invitation and seminar. And we appreciate the warm welcome. April is the slide operator. April does all the work in this project, including managing the slides. So if you want to get that started, April, I will give a little bit of background on this project. So in 1999, I approached the publisher of MIS Quarterly, who was Gordon Davis at that stage, who's a famous name in our field, and said, we need a review section in the quarterly. And he agreed. And so I was appointed as an SC to implement this idea and start the review section. And so I don't see the slides yet, April. Can you?
Oh, you would like me to share the slides?
Yeah, because you've got all the slides.
No problem.
Yeah.
See, share slides, desktop.
Okay. Yeah, and if you can just go to the next page. Yeah. So when I started this project, I quickly discovered that many people didn't know how to write a literature review. They were basically summarizing the literature instead of synthesizing it. So in 2002, Jane Webster, who replaced me as the senior editor for MISQ Review, and I wrote an article on how to analyze the literature and telling people that the way to go forward is to be concept-centric. Concepts matter more than authors. That has become widely adopted as a method for reviewing the literature. We were approached about 2 years ago by the editor of the Journal of Decision Systems, who said, why don't you update that paper? Let's go back and have another look at it. So we decided we would first develop a roadmap because we're ambitious. We thought we could revise this and we could get another MISQ article out of it. And so we wrote a roadmap, which was published in the Journal of Decision Systems in 2020. And I met up with Jane in Kingston in Canada. And on the way back, I was sort of half asleep on the plane. And I had this notion that I could bring together two ideas that I was been sort of wandering around in my mind. One was graph databases. I was teaching that. I thought it was an important development. It had recently been standardized in terms of the language for creating and querying them. And the other thing, I was reading the work of Pearl, I should say, on the core of knowledge being a causal model. And I realized that a causal model was a graph. And if we coded all of these and put them in a graph database, we would have a knowledge system. And this would be a way to move forward and automate to a large extent, digitize literature reviewing. So we started in that direction. And I recruited Xia and April to work on the project. We now have a paper under review at the quarterly, which is a revision of the original paper with Jane in 2002. Jane is also a co-author. And we have developed this new method. It's motivated also by the fact that the startup time for researchers is getting longer. And please go forward. Oh, just go back one. Did you go back one? So the approach that we've taken is yin and yang. Yin is analyzing the past, which was the theme, one of the themes of the first paper. And this is what the T-Rex project is about. It's developing the technology to support analyzing the past. There's still the yang piece, which is preparing for the future. And that was part of our original paper as well. And Jane and I have interviewed a lot of scholars to find out how they develop theoretical insights. And the yin and yang together composed the paper that we've recently submitted for consideration. Next slide, please. So why do we have to develop better methods for literature reviewing? Well, we have this mountain of knowledge, and the mountain keeps getting higher and higher. And it takes a lot longer for scientists in all the various fields, the social fields and the physical fields, to produce their most important work. And that time has risen by 6 years in the course of the 20th century. So we have to spend a lot more time in investment in learning the field, and our careers begin later. But people are no more productive. So they have a shorter span to be productive. In fact, a compounding problem is the fact that people generally do their best work early in their career, particularly the breakthroughs in areas like physics and science come early in one's career. So we have longer education, but shorter periods of productivity. We need to find a way to help people get up to the frontiers of the field more rapidly. And the way we do this in every other area is to digitize our information. And that's essentially what we're arguing for today. Next slide, please. So Judea Paul has done a lot of work in this area, and he says causal explanations, not dry facts, make up the bulk of our knowledge. It's our understanding of how things happen, the relationship between a cause and effect. That is the core of knowledge. And this is a graph. Next slide, please. And here's a simple way you can think about it. Concept 1 impacts concept 2, impacts concept 3. That's a causal model. That's a graph. We can code it as a series of nodes and edges. And if we look at academic papers, many of them contain causal models. And so we can fairly quickly code these and put them in a graph database. Next one, please, April. So phase one is we're trying to code the minimal amount of data to have a useful system. And it's a little bit like thinking about a business. You don't want to try and do everything, but you do want to build enough so that you can understand the business. So we want to go beyond one transaction or one record to a whole collection of records so that we can understand the core of knowledge. And we're trying to get there on the fastest path possible. And then later on, let researchers tell us what are the nice to have bits, what are the bits that would improve their ability to synthesize literature. So next slide, please. So here's our graph database. And fortunately, Xia's kids have a colouring in book of a T-Rex. And so we've used that to show our model. And you can see the core is the model. We record which publication it appears in, who the authors are. We code up the elements, and the elements are concepts, constructs, and procedures or temporal aspects in a process model. We record how they relate to each other. We record the definitions of the elements, where they occurred originally. And then we record any theory that the model uses, the theory that informs the model or informs a particular element, such as a concept. So we take a graph, causal model in a paper, and code it up in this manner. Next one, please. And so this is the progress that we've made so far. We've written a program called Codasaurus, and that uses things like the ORC ID, the author's identification, to go out and get details of the author. It uses the document object identifier to get details of a document. And what we try and do with Codasaurus is to make it very easy for an author or a scholar to code up a causal model. And you'll see April will demonstrate and show you how we use it and how it generates all of the cipher code, cipher being the language for creating a graph database. And once the graph database is prepared, then we can do queries and analysis. And this is our second program that we're starting to work on called Analysaurus. And we've done some of the querying and visualizing that you'll see today, and we're working on some of the analysis. So the yellow dots represent some of the progress we've made, but in the long run, we will have a set of tools available for analyzing a knowledge network. Next slide, please.
I think that's the end of this.
That's the end, that's what I thought. So now I'll hand over to April, who is going to talk about how to use Codasaurus to give you an idea of how easy it is to code a publication.
Okay. So can you see the PDF and the Codasaurus?
Yes.
Okay. So today my presentation has 3 parts. First, I will demonstrate how to use Codasaurus to code a paper. And then I will visualize the coded paper in Neo4j, which is a software for graph database management. And after that, I will do some queries to show some potentials with digitized publications and knowledge. So let's get started with Codasaurus. So Codasaurus is written in R using Shiny package, and it is available for our website. I will share the link later. What this app does is to ask a set of information and generate the cipher code for people for a digitized publication. So let's get started with the publication box here. This box asks the citation of the publication, and we can do that in 2 ways. We can either input the DOI of the publication, and the app will use the API to find the citation for the publication, or we can manually copy and paste the citation here. Currently, our app is having issue with the API, but we have someone working on this and hopefully to address this issue soon. So today I will demonstrate how to use the menu option. So to do that, we can copy and paste the citation, for example, from Google Scholar. And to save time, I have already found all the information we need. So I will directly just paste it there. After that, we click the Save Publication Input button. And as soon as I do that, you can see the cipher code is generated on the right side. Next, we can move on this element box. So element is a general term we use for a construct or a concept or a process. So this box is asking you the name for the element and the type of the element, construct or concept or process, and what role does the element have. No role means the element may be a simple consequence of a relationship. If the element has special roles, such as moderator or mediator, we need to indicate that here. So let's go to the causal model for this paper and code part of it. This is a causal model the paper has. And for demonstration, I will do this part to show you how to use CodaSource. So first we have the construct actual repurchases. And we put the name here, we choose construct and no role, and we move on to the next one, which is repurchase intention. Same thing is, it is also a construct, also has no role. The next one, Swift 关系, same thing. And the last one, trust. So once you finish a box, you need to remember to save the input, because the later boxes will use the information we've just put in there. So next thing, we can move on to the next definition box. So it is very straightforward. It asks you which element you want to define and the definition for that element. So here, let's just do one definition for trust and save the definition input. The next box is about research model. It asks you the name of the research model. You can simply put research model here. And what element does the model depict? In this case, we will choose all of them. Sometimes a paper can have more than one research model. For example, if their empirical findings are different from their proposed research model, they will have a revised research model to reflect their empirical findings. So in that case, we recommend you to also call the revised research model. So in this case, for this paper, their hypotheses are fully supported. So we don't need the second model. I will remove it here and save the model output. The next box is about elements. So this box is about the relationship between elements. It asks you what is the antecedent of the relationship, which is the consequence of the relationship. And you can also put the description of the relationship if you want. And also what type the relationship is. Is it a causal relationship or temporal relationship for process models or correlational relationship? You need to choose accordingly. And also what model did the relationship come from? So let's just do 3 hypotheses to demonstrate how to use this. So first we can see hypothesis 1 is from repurchase intentions to actual repurchases, and we choose accordingly. The second hypothesis is from Swift 关系 to repurchase intention. Swift 关系 to repurchase intention. And the third one is from trust to repurchase intentions. Trust to repurchase intentions. And we save the element input. The next box is about authors. So it asks you the name of the authors and the ORC ID for the author. To do that, we go back to the start of this paper and copy the author's name, first name, middle name, last name. The other thing we highly recommend is to put the author work ID here, which is a piece of code that can uniquely identify the author. And to do that, we can go to work ID website. See, let me share this here. Okay. And search the author's name in the searching box. You can see it is quite common that people have the same name. And in this case, we can use affiliations to help us to find the person we're looking for. And you can see here we see EIS, we see City University of Hong Kong, which is an indicator that is the right person we are looking for. And we copy and paste work ID here. The next box is about theory. Okay, so I just made a mistake. I forgot to save the author input, which was not what you want to do because the cipher code will only be generated after you click the save button. So the final box is the theory box. It asks you the name of the theory and what item does the theory relate to. So a theory can relate to different things. It can relate to the publication node. It can relate to the research model node. It can relate to the different elements. So we should faithfully code what the paper says about the theory. And oftentimes that involves taking a closer look about how this paper discussed the theory. So for example, in this paper, media synchronicity theory is one of the theories they used, and they use it as a theoretical foundation for the paper. So I will choose publication here and save the theory output. So far, we have finished all the boxes. The next thing we need to do is to download the cipher code. And let me show you the cipher code we just generated. So you can see here, even though we just coded 3 hypotheses from the paper, it is still quite a bit of coding we need to do. And this will take much longer if we did this manually, just do all the coding by ourselves. And that is the reason why we created this software in the first place, to make things easier for scholars. So the next thing I would like to show you is to visualize the coded paper in Neo4j. So here, what I'm sharing is an empty database in Neo4j, and we will copy and paste the cipher code for this paper here to this database and run the query. And you can see here, when the query is successfully processed, it will show a green check mark here. And this shouldn't take long. It will be very quick. And we can also see the nodes are added when the code is processing. Okay, so here, do it this way. Here, this is the digitized model for the paper. We can see here we have different colors, which indicates different types of nodes. So the blue ones are this one is the publication citation. And we have the red ones, which are the definitions for concepts. We have the brown ones, which are the concepts. And we have the research model and author and theory. What we can also do is we can take a closer look of this research model for this paper. So that's the visualization part. Let's go back to Neo4j, and I will demonstrate to you some queries. Let's see. So this database is all the MIS quarterly curation papers that have an explicit causal model. And I coded all of them this summer. You can see this is a fairly large database. It has 3,000 nodes and more than 14,000 relationships. So this is going to take a little bit while to open. While we are waiting for this, let's see if we have any questions for previous parts. No? Okay. Okay.
I do have, okay, since I was going to have a question for you, but now it is open, so you can go ahead.
It's okay if you have a question to ask.
We can leave it at the end if you don't mind.
Sure. All right. Okay, let's first do some visualization of this database. See. So you can see as we put several papers together, the database gets complicated pretty quickly, and it soon overwhelms human bounded rationality to process all the information. That is why we are developing analytic tools for us to maximum the value we can get out of the database. So let me go back to here. Okay, that's better. So here are a set of queries I would like to show you today. The first one is to find all the theories we draw upon in the curation. And this query shows us all the theories in the database, and the frequency of the theory has been discussed in these papers. You can see institutional theory is a popular one, discussed 6 times. Agency theory is popular, and so on and so forth. This is much more efficient than we do a search in a full text search engine such as Google Scholar, and then try to identify all the theories by ourselves. The next piece of theory I would like to show you is to find all the definitions of the concept. This case, I'll use trust as an example. We can see trust has 9 different definitions in this curation, and the simple query can find all the definitions very quickly. The next query is to find all the antecedents of a concept. So trust is an important concept. What are other concepts that has a direct impact on trust? And we can see in this graph, we have trust here, and all other nodes has a direct link to trust. And we can also twist the queries a little bit and find the name of other constructs and give us a table instead of looking at this complicated graph. And here are the names of the concepts that has a direct link to trust. And similarly, we can find the consequences of trust. This is trust. Other nodes has a direct link with trust. The next thing we can also do is to find what are the outcome variables has been discussed in these curation papers. So to do that, we can sort the incoming edges a node has. The more incoming edges a concept has, the more likely that concept is often studied as a outcome variable. So we do this query, and we find all the names of the concepts and the number of their incoming edges. And we see these curation papers talked about performance, talked about trust, talked about behavioral intention. And these are the things IS scholars are interested in. So these are some simple queries we can do. And Xia later will talk about more potential research directions we have identified. If we don't have questions for me at this stage, I will hand it over to Xia.
Okay, any questions for April? Okay, then I can continue, and we will have some time at the end of the presentation for question and answer. So once the knowledge is digitized, we have many opportunities to extract the knowledge and to synthesize the knowledge. And we can apply existing methods, or we can develop new methods. So we can use like machine learning methods, we can use natural language processing methods, and we can use the methods and the tools developed in DAG theory, graph theory, and we can use social network analysis. So here I just illustrate an analysis method map. So we pinpoint 5 levels of analysis: element relationship, model, theory, and theme. And you can see we can use different methods at each level. And we expect as future research advances, more methods will emerge, and we can apply those new methods. Okay, first I want to illustrate as an element level what analysis we can facilitate. As an element level, so we can do a few tasks for knowledge extraction and synthesis, like information retrieval. We can use several queries to retrieve information about an element, such as the element's definition, the associated publications, authors, research models, and the theories. So April has already illustrated how to run several queries and to retrieve definition. And you can see, so when you network, as your network grows, and the elements and the relationship will grow quickly, and using the several queries, you can quickly identify the information you are interested in, and it helps you narrow the search scope for you. And we can also do some similarity analysis between elements. So we can analyze the similarity level between elements based on labels or based on definitions. And natural language processing has some methods we can leverage, like the BERT tool. And also, we can help resolve jingle and jangle fallacies. What are jingle and jangle fallacies? The jingle fallacy occurs when 2 concepts have identical or similar labels, but reference different real-world phenomena. The jangle fallacy occurs when 2 concepts reference identical or similar phenomena, but are labeled differently. So you can see, once we code more publications into the database, the knowledge network grows, and you will find similar concepts. They may represent similar phenomena or different phenomena. So it's hard for human beings and to find the similar concepts or find the different concepts which essentially represent the same phenomena. Using the similarity measures, so we can actually compare any 2 elements, and we can produce a similarity matrix. And then you can inspect the matrix and find out the elements with higher similarity level and the elements with lower similarity levels. And then you can further inspect those elements or their definitions to see whether there are any jingle or jangle fallacies. We can also analyze the elements and see the similarity between the elements and group those elements, and then we can identify the research themes. So like we can organize the concepts, so definition as vectors, and using machine learning method like cluster analysis and to group the concepts, and then we can see the different themes in our knowledge network. And over time, we can also see how the themes evolve. So this slide shows an example of semantic similarity of concepts. So those similarity measures are based on concept label, so the concept names. So in the first column, you can see one concept. In the second column, there are another concept. And you can apply different measures, like for the string-based measure, the first two concepts are similar, the level is 0.667. But if based on corpus measure, so it's almost the same. And if we consider the knowledge, so what actually these two concepts represent, so they are the same concept. And like the third group, risks and costs, and you can see string-based measure shows the similarity is 0. But if we look at a corpus-based measure, the similarity level is about 1. So that's because these two concepts often appear together. But if we use knowledge-based measure, so the similarity level is only 0.167. So actually, leverage different measures, and you can see the similarity of concepts on different dimensions. And using several queries, we can retrieve the definitions and the defining publications for an element. So this table just summarizes what April showed you using several queries. And you can see in the MSQ trust curation, there are multiple definitions for the trust concept. And then you can read the different definitions and see which publication those definitions appear. So as the number of definitions grows, it's getting more difficult to review all the definitions. But using the similarity measure, so we can produce similarity metrics. And here you can see definition 1 and the definition 5 has the highest similarity level. Definition 1 and definition 7 has the lowest similarity level. And the definition 5 and definition 7 has the lowest similarity level as well. And the overall definition 3 has the highest average similarity level with all other definitions. So in this way, you can focus on several definitions, not hundreds or thousands of definitions for a contract in a huge knowledge network. Just now, I showed two examples for the element level analysis. So, in a knowledge network, elements are connected. A research model has element and a relationship. So without a relationship, it's not a complete picture of the knowledge. So we can do analysis at the element relationships level. So for example, so we can help retrieve important information. So we can retrieve elements related to elements, such as the elements antecedents, consequence, or passes starting or ending with the element, or between two elements. And we can use several queries and to retrieve the elements and the relationship and construct passes. So we can also use graph theory method like shortest path analysis and to identify the important mediator. So those mediators with direct impact to other elements. And we can also use social network measures and to evaluate the importance of an element in a knowledge network. Like we can use the in-degree, out-degree centrality, betweenness centrality, or closeness centrality measures, and to see how important an element is in a knowledge network. So this slide shows you the antecedents of trust. So you can see trust has been well started and it has many antecedents. You can also add conditions to your sample queries and to filter the antecedents. And these slides show you the causal paths starting or ending with trust. So you can use sample query and to construct the causal paths. So it illustrates a chain of cause-effect relationship. And this table shows you the network centrality measures for some concepts. And you can see for trust in the MSQ trust curation, and the betweenness centrality measure is as high as 726. So that means trust is an influential mediator. And the closeness centrality is also very high compared with elements. So that means the trust in aggregate has a high direct impact on all other elements in the curation. And the out-degree centrality shows the trust is a fundamental antecedents, and the in-degree centrality actually suggests a trust is a well-started consequent. And in this way, you can evaluate the importance of different elements. And at the model level, so we can help resolve jungle conundrum. So what is the jungle conundrum? It's similar to Jingle and Jangle fallacy at the element level. So we define jungle conundrum as the identification of similar causal models in a large knowledge network. So as the knowledge network grow and some models are very similar, but it's challenging for human being and to identify the similar model. So we develop some graph isomorphism analysis, which will help researchers to identify similar causal models. So in particular, we develop a conceptual isomorphism measure. So this measure is an integrated measure. It considers both the element similarity and the graph structure similarity. So it will help you to compare different models and report the similarity level. And I will show an example next slides. And at the model level, we can also help identify and resolve the endogeneity issues. So we can help identify potential endogenous variables and to see whether there are any omitted variables or whether there are some simultaneity issue or reverse causality issue. So we can also apply DAG analysis methods such as identifying and direct paths, backdoor paths, or colliders, and to identify and resolve the endogeneity issues. And we can also use social network methods and to identify critical elements in a knowledge network. For example, so we can use structural cohesion analysis and to identify the critical nodes that connect a model or bring different models together. So those elements are very important because they are started in different research models, and they serve as a bridge between different publications. And you can further explore whether there is any research opportunity. And these slides show a model conceptual isomorphism analysis. And here you can see two privacy models. And they have similar elements, and the model structure is similar. And the conceptual isomorphism score is 0.636. So it indicates, these two models are highly similar. So it's easier to evaluate the similarity, with only two models, but with a huge knowledge network, hundreds, thousands of publications, it's getting very challenging. And using the graph isomorphism analysis and the conceptual isomorphism score, and you can filter the models using the tools, and then you can manually inspect those models and to gain some insights. At the theory level, so we can also facilitate some knowledge extraction and synthesize tasks. So theory guides knowledge creation is very important to identify theory in a knowledge network. So using several queries, you can retrieve the theories used in different publications. You can further count the frequency of theory appearing in a knowledge network. So in this way, you can evaluate the impact of a theory in a knowledge network. So this slide shows in the MSQ trust curation, there are different theories have been applied. And also this table reports the frequency of those theories. And you can see, and there is a wide coalescence among the publications. So actually, scholars do not have agreement, which theories are the critical or fundamental theories for trust. At the same level, we have also identified some tasks, graph database and associated tools can facilitate. Like we can use knowledge, we can evaluate knowledge fragmentation. So using the network density measure, and we can compare network and to evaluate the cumulative nature of a knowledge network. And if a knowledge network has a higher density, that means the elements are well connected, and the knowledge network is cumulative in nature. Otherwise, it's not cumulative in nature. We can also use social network analysis method to identify the gaps in a body of literature, like using the structural hole or weak tie analysis, and we can see how the elements are connected and what are the critical elements, and then we can further evaluate whether there are any future research opportunities. We can also do some comparative analysis, like we can track the development of research theme by journal and during a period of time. So like we can use the cluster analysis method and to group concepts, definitions, and theories in a knowledge network, and to identify the themes in the network, and also to see how the themes evolve over time. And we can also do some model integration or simplification. So as the knowledge network grows, the structure is getting very complicated, and we can apply some graph summarization method and to simplify the model and to simplify the structure. So in this way, we can have a more abstract, higher level view of the knowledge network. And this will help us to better understand the knowledge in a body of literature. Okay, so just now I quickly give a quick overview of the analysis we can facilitate with the graph database and some methods we can apply and to conduct the analysis. As I said at the beginning, we expect new methods will surface, and we can do more knowledge extraction and synthesis applying the update method, the cutting edge methods. And April has already shown you how to use the supporting app to code a publication. So the app is called Codesaurus, and we will share the app with you. And then you can code your own work, or you can code others' work when you are conducting literature review. And we are in the process of designing and developing a supporting app for knowledge extraction and synthesis, and it is called an Analysaurus. And those analysis tasks I have introduced can be considered as the user cases for the app. So we plan to develop tools to do those analysis automatically. So in this way, we hope we can help scholars to better extract knowledge and synthesize knowledge during literature review or during their research development. Okay, that's all I want to share with you. And I thank you very much for your participation. And here I have our emails. So any feedback is welcome. Any comments, suggestions, questions. So we would like to hear from you.
Thank you so much, Professor Watson, Professor Zhao, and April Song for this really informative presentation about this project. I've been really interested in doing that actually in the Chief Information Officer literature for a while, but now I think I'm going to proceed with that since I see that all the tools are like available, and now I have much clearer kind of, understanding about the whole approach. If you don't mind, we can open the floor for any questions. If you have any questions, you can raise your hand, and I believe you can speak in the mic if it is available, or you can put your questions in the chat or in the Q&A so that we can our guests can answer them. Yes, Musa, please go ahead.
Thank you, Martin. Interesting presentation and a really interesting tool to synthesize, the literature and the paper, and it's a good way actually. But there are, when I was tracking the presentation for April and Xia, there are many things coming up in my mind. So for the first question, I have a couple of questions, but I will ask them to stop and give the floor for others. First questions, And the Chia, our program, there was when you selected construct, there are three things there. Mediator, moderator, and no role. So it wasn't clear for me why no role there. Yani, I believe all constructs usually comes with a role. Is my question clear?
Yes, I think I understand your question. So for no role, it means a simple relationship from A to B, and there's no mediator or moderator. And in that case, concept A and B will be coded as no role. Does that answer your question?
So is yeah. Is this like an antecedent? If we go with no role, it means okay, antecedents. Okay. Since if it is maybe labeled antecedent, this is will give more clear message. This is antecedents, because usually constructs comes with a role. Okay. The other questions I have for Chia, when you brought those nice diagrams, and you showed the trust with many antecedents, and relates to, and this one, this is very nice. But I was thinking, is there a way that we incorporate correlations here, like we know trust is being the outcome variable here on all our antecedents? So like, for example, if I'm looking at maybe product type or credibility or knowledge-based or human images, is there something in the tool that gives me the correlations? Or could I make another, like a graph showing the correlations?
You mean the correlation coefficient of the relationship?
Basically, so here the trust is like a dependent variable, and all others are independent. I mean, those all come from different studies. But from which study they grab this? They grab this. It brings the correlation between trust and this. So usually, in whatever study we develop, there is a correlation table, and it gives us how much the X correlated to B. So here B trust and X whatever independent variables. Is something or like another graph we could create that shows us those?
So let me answer that one. We do record if the relationship is causal or correlational, right? But you might remember at the beginning, I said we're trying to build a system that is minimally useful, right? And to code up all of the data about the measure of the correlation and the p-value and things like that is a lot more work. And we don't want to get into meta-analysis, but rather conceptual analysis. And if later on people say you must have this, then we'll do that. But we're trying to get something very useful very quickly.
I see.
Yeah.
Okay.
So even though we cannot report the correlation coefficient or the coefficient of the causal relationship, but we can report the frequency of the antecedents being started, like the in-degree centrality measure. It tells you, how many antecedent element has. So actually, we can further calculate, between two concepts or elements, how many times they appear in the network in different publications. How many times the relationship appear in different publications.
Okay, and do you take into account whether those antecedents were significant or not?
No, at this time, we don't report like the p-value, those coefficients. So as Rick said, so we want to minimize the work, and we want to capture the most important things in the knowledge network.
I see. I see. My last question in this round. Do you guys have something like, I don't know, a paper that using the TRX project, and so we can look at it and, you know, understand what's being explained here, or there's something cooking maybe?
Sorry, sorry. Can you say it again? So
yeah, I think I heard it.
Okay.
We've got a couple of papers which you can get from our website. There's one on how to use the coder, how to code it up. It's similar to April's presentation. And fairly soon, April will post her ISIS paper that talks about the jingle and jangle fallacies and the jungle conundrum and how we resolve those. And then we have a more advanced paper under consideration that looks at all of the tools that we're planning to develop and how you might use them. Actually, the ISIS paper is there. April's posted both of those, so you can see them.
Okay, this is great.
Yeah.
Thank you. Thank you very much, Rick. Okay. All set from my side.
Thanks for your good questions.
Thank you, Musa. There's a question in the chat by Amir Abbasi. He says that here in this, I believe he's referring to this figure, there is only a depiction of the antecedents and the consequences, but no indication of moderators and mediators in such studies. I assure those studies will have mediators and moderators, but these are ignored in the review process. Why is it so? So I think he's referring to the, like, maybe depicting the mediators and moderators like here in this antecedents of the trust figure.
Yeah, remember, it depends upon what you code to start with, and we have coded moderators and mediators when they're in a model, and therefore we can use Cypher to extract moderators and mediators. And we're just showing some of the possibilities here, not all of the things that you can do. But certainly we know what the moderators and mediators are for any model if they've been indicated when the person presented that model in the publication.
Great. I also have a couple of questions, if you don't mind. Sure. So to start with the first one, so basically I'm these days I'm involved also with the project in reviewing the CIO literature, right? And one of the steps that we had to do, and on which we had to make like our own decision to proceed with our literature, is that like to decide whether to include qualitative studies or not, because usually like in qualitative studies we don't have like an explicit model like we see in these quantitative studies, right? So with this TRX project, are these qualitative studies, like, I don't know how to say, like ignored or removed from the TRX project, or how should we proceed with these qualitative studies?
So remember, the core of knowledge is a causal model, and that's our starting point. So we're only coding those. It is feasible to code qualitative models. We could put in the theory and the concepts and the definitions, but we're not going to have a causal model there. What we're suggesting is that when you do this work, you might then go back and look at the qualitative work that might have preceded it before someone did an experiment or something like that. But we're just focusing on what Pearl says is the core of knowledge.
All right, awesome.
I mean, if you decide to go down that path, then we could look at how we could add that sort of coding capability, at least the theory and the concepts that are in the qualitative paper. Potentially things we can code.
Yeah, because it's my concern that if you do not include these qualitative studies, you might basically, ignore a huge part of the literature or a huge part of this, studies that might blind you to different kinds of, conclusion results about the phenomenon of interest. So this is, so maybe eventually my TEDx project or coding will become in a way biased because I'm looking at a certain type of studies. Is this like well justified, or is this something that can be resolved like in the future, maybe?
I think you have to do both together. You have to identify the qualitative studies. And certainly if you find, trust is really important, then you should go and look at the qualitative studies as well as the ones that we've been able to code. Right? But yeah, it's not a complete answer. But I think April found in some cases of the curations, 80% of the papers had a causal model.
Mm-hmm. Right. I see. Awesome. The other question is about how can we differentiate in the model between like saying that this relationship is causal or this relationship is correlational in this case? Because usually like in the hypothesis, I mean, the authors claim that they have some kind of causal relationship between the A and B, for example. But maybe when they do their actual analysis, they do like, different kind of, statistical methodologies that might not reach the level of actually capturing the causal effect of A on B. So how can we, differentiate in this case between a relationship that is causal or a correlational?
So they could start with their initial research model and they propose that it's causal, in which case they would code it like that. There's a choice of causal or correlational when you code. They might then revise it later and decide that that relationship is correlational. That's one of your choices when you code the relationship between two concepts. And you could also code it as a process. So we give you three choices. Mm-hmm. Right?
Okay. My last question is about actually, in these, econometric papers where we see a lot of, especially like they basically are interested like in 2 or 3 variables and they include all types of control variables. Now in the TEDx project, should we also capture these control variables and include them as variables in our, coding or not in this case?
You should capture them and you should indicate that they are moderators.
Moderators, yeah, perfect. All right, this is all from my side. Thank you so much. And I believe we have, if anyone, Dr. Ibrahim Al-Jabri has raised his hand. Go ahead, Dr. Ibrahim. Allowed to talk. Okay. Now you can open the mic.
Do you hear me now?
Yes.
Okay. Thank you, Rick and Zhao and Song for your presentation. I'm very happy to meet with you virtually. Very interesting project. I like it very much. But from information system, the quality of the analysis depends on the quality of the data.
Yes.
Garbage in, garbage out.
Yes, yes.
Then do you have a selection criteria for the papers that you include in the database?
So we've only coded the papers that are in the MIS curations, just because this is not meant to be a representative database. What we are trying to show what the possibility is if you select papers for a particular literature review. Then those are the ones you might code, and it's your job to have a representative or good representation of all the papers on a particular theme. The long-term goal is to ensure quality, is to make this a standard when you submit a paper to a journal that has a causal model. As part of the reviewing process, your description of that model would be validated, and then it would go into our database. Alternatively, we gradually accumulate the data from literature reviews. And so when someone does a literature review, they submit it for review, and that includes reviewing the coding. and then that would go into the database. So over time, we need to build up a knowledge network by making this a standard. And so we're going to talk to the International Standard Organization to propose that what we have is a standard for coding knowledge and work through the process of getting that accepted.
So for you start, for example, for top MIS journals, for example, the MISQ, ISR, MIS, or what is the, to start with then?
Yeah, we're not going to code those. It's just too much work. What we want is the journals to say, this is the standard. And then people, as they do their literature reviews, submit them to the database. So we have to set up an infrastructure to manage the collection of this knowledge. Yeah.
Yeah. Thank you.
Yeah. Okay. Good to hear from you, Ibrahim.
Thank you.
We have a question in the chat from Mahmoud, and he said that what is the extent of using such model when reviewing literature of patents? Is this
yeah, I saw that. I have no idea. I don't know much about the literature of patents, but you know, we could talk. And if the papers do have causal models in them, then we can do a fair bit of coding. I mean, if you work in a field where people don't produce causal models, then you're not capturing the core of knowledge as defined by Pearl. And so we can't move to the stage of having a graph database.
Mm-hmm. Great. Any more questions for our guest speakers regarding their fantastic project?
Oh, very good questions. We appreciate them, and they help us to think about how we're going to move forward on the project.
Yeah, technical questions. Everyone should start the presentation. There were two options there, the manual and the OI. So you guys are still working on that, since that is going to be easier to upload whatever when we you know, wanted to select it and get it into the project or the tool.
Yeah, we had DOI working, and then there was some change in the API. Mm-hmm. And then we changed programmers as well. We get a different programmer each academic year. So DOI and also OrcID, eventually you just put those in and it will retrieve all of the information. All right. Mm-hmm. So that will reduce the work. And we're trying to do that all the way through, right? Yeah, we're not too far away from doing that. I have a meeting this afternoon with the coder to try and accelerate that, right?
Okay.
Yep.
This is good. This is good. Okay.
We're trying to make your life easy, right?
Yeah. Always. This is what we do in IS.
It is definitely an amazing tool that we all can use, you know, to understand our literature, because really doing stuff like in the old ways or the manual ways, I mean, will make you, you know, skip important stuff like, you know, representing the relationships between the different variables in this graphical format and trying to find the different themes using different, you know, analytical techniques and looking at the graph from some kind of a network theory perspective. These will basically reveal a lot of, you know, information and insights that we cannot do them in the traditional ways. So,
that's right.
So I'm really excited to use this tool, and I really encourage everyone to use it in their future research.
Thank you, Martin.
Thank you. And thank you so much again, Professor Watson, Professor Zhao, and April Song for your time and effort to present to us this really amazing tool. You have their emails, our guests and audience. If you have any questions, they are more than welcome to answer them. And we will see you in our bi-weekly meetings from our Research Center in Finance and Digital Economy. Thank you so much for attending, and thank you so much, our guest speakers, for presenting your project.
Thanks for the opportunity. Bye.
Thank you.
Thank you. Bye.